For our next unit, we're looking at area of figures, and we're going to start off with simpler shapes before we expand on that. So starting off, we're looking at the area of triangles, rectangles, squares, parallelograms, trapezoids, and circles. So these are things that will be on your formula sheet. They should be pretty straightforward for you. So just as a reminder, when we're looking at the area of a square, we're squaring our side length. If we're looking at a triangle, we're doing 1/2 base times height. Looking at a parallelogram, we're doing our base times our height. Remember, the height is what's inside, so it's that 7.1. You can also use the picture to help you figure out which one is the base and which one is the height. For number 4, we have a circle. For 4, we needed to cut our diameter in half to find that radius, and then we can find our area very easily. Couple more shapes to look at that are simpler. Number 5, we have a trapezoid. With a trapezoid, we do have a little bit more complex of a formula, so it's 1/2 times our height, and then we have 2 different bases, so we're adding them together. So 19 and 27 are our 2 bases. 6 is another rectangle, so just the sides multiplied together. Number 7, we have a triangle, and in this case, our height is outside of our triangle. They just couldn't show that inside, but it's the same height. Number 8, another parallelogram. For number 9, we're looking at a semicircle. So we're going to start off with finding the area of a circle, and then we'll cut that in half. So 17 squared times pi would give us the area of our circle, and then multiplying it by 1/2 gives us half of our area. And then last, we have one more trapezoid for number 10. Again, our bases are 7 and 13, and then we're multiplying by our height and 1/2. When we're measuring area, make sure that you are doing our measurement and then squared, so inches squared or feet squared. Those shapes should be a review. The newer shapes are areas of regular polygons. So a regular polygon that has even side lengths. When we look at a regular polygon, we have some different parts that we're going to be using. So the first part that we're going to need is the distance from the center of a polygon to a side, and that's our apothem, and that's marked by A in our picture. The other thing that we're going to need is the radius of a regular polygon. So the radius goes from our center to our vertex, so one of the points of a polygon. And when we look at the area of a regular polygon, we're using this area formula right here. So we're doing 1/2 times the apothem times our perimeter. And perimeter is referring to all the way around our shape, so just adding up those different sides. So we'll do a couple of examples. For number 1, we're going to start off with figuring out what our apothem is and what our perimeter is, and then we can plug it into our formula. So the first thing is that apothem is 7, so that's from the center of our triangle to the edge. And then our perimeter is taking our outside length and just adding it 3 times, or we could do 24.2 times 3, and that gets us our perimeter of 72.6. Then we're going to plug that into our formula, and we'll find the area of our triangle. This also works with other polygons. So looking at example number 2, our apothem is 16, and then we're going to find our perimeter. So this shape has 1, 2, 3, 4, 5, 6, 7, 8 sides. So we're doing 13.3 times 8 to get our perimeter of 106.4. Once we have the apothem and the perimeter, we're just plugging them into our formula and multiplying. These problems get a little bit more complex when they don't give us all of the information that they need. So sometimes we will be missing an apothem or we'll be missing a side length, and we're going to have to do some work to find that. So the steps to do that are listed above. The first thing that we need to do is we need to create a right triangle by drawing the apothem and our radius. So if it's not already drawn, we're going to draw it in, like for number 3. Then what we need to do is we need to find the measure of the interior angle. So we're finding one of our angles here using this formula. Formula is n minus 2 times 180 divided by n. N in this case is our number of sides. So again, if we're looking at number 3 here, there are 6 sides to our shape. So what we would do is 6 minus 2 times 180 divided by 6. That's what's giving us this 120. From our 120, what we need to do is we need to divide by 2 again. The reason we're dividing by 2 is the radius that we drew down cuts our angle perfectly in half. So half of 120 makes this angle 60 degrees. Now that we have a right triangle with one of our angles, we can either use our special right triangles or we can use our trig ratios to find the apothem or the side length that's missing. So looking at this problem right here for number 3, we have the apothem is 5. What we need to find is our side length. So if we isolate our triangle right here, what we're finding is the part of our side length, our x in this picture. The x is going to help us find the entire side length. Since I have a 60-degree angle, I can use my 30, 60, 90 special right triangle, and I can say that x is equal to 5 over the square root of 3. Now, typically what we do is we write this as a rational fraction, but in this case, we are going to go ahead and do a decimal approximation since we're finding our area. So the decimal approximation for x is 2.89. That is just half of our side length. So in order to find the entire thing, we are going to double that, which is why we have 5.78 written down here. Once we have 5.78 for our side, we can go ahead and find our perimeter. And now that we have our perimeter, we can use the apothem and the perimeter to find the area of the entire polygon. We're going to look at example number 5 now. So for number 5, the first thing that we need to start with is drawing that right triangle. When I draw my right triangle, I'm drawing in that radius. And then what we need to do is we need to figure out our angle measure. So again, I'm doing the number of sides. In this case, it's 5 minus 2 times 180 divided by 5, and that gives me each angle is 108 degrees. So when I cut that in half, that means that this little angle down here is 54 degrees. Now that I have my angle, I need to figure out what I'm trying to find. They gave us our apothem, so what we're doing is we're finding our side length. And in this case, I'm going to be using one of my trig ratios to figure out what x is. The trig ratio that I'm going to be using is tangent. So the tangent of our angle is 10 over x. And when we solve for x, we get that it's 7.27. That's just 1/2 of our side length. So we're going to double it to find 14.54 as the entire side. And once we have 14.54, we're going to use that to find our perimeter. After we have our perimeter, we're going to take the apothem and the perimeter, multiply those together, and cut it in half to find the area of the entire shape. Number 4 and 6 are done the same way. So number 4 is an example where we would use our trig or our special right triangle. And number 6 is an example where we would use our trig ratios. A little bit more complicated, but again, we're still just using the A equals 1/2 times the apothem times our perimeter. And all of that is for our area of our figures.